in lesson 7.1, we are going to start looking at inverse trig functions. And the first part of this is actually using the calculator to calculate some trig functions or some trig ratios. And we have to make sure that we are working in the right mode. And you've probably noticed before that on your calculator, you can have a degrees mode where your answer will be measured in degrees, or you can have a radian mode. And if you are working on decimals, you can change between degrees and radian modes by using the little wrench that's up in the top right corner. And looking at that menu at the very bottom, if it's highlighted in green in degrees, then you're working with angles in degrees, and if it's highlighted in green with radians, you're working with radians. Although I do want to caution you that should your answer be pi, it will still give you a decimal value. So if your answer is just pi, then it will say 3.1415926. If your answer is 2 pi, it will say 6.29, blah, blah, blah. So when we're working with radians, most of the time we're going to be working on the unit circle. But just some practice in terms of calculating with degrees and with radians. Make sure that your mode, and if you're working with a calculator, if you look at the mode here, right now I'm in radian mode because it's highlighted in black. To get into degree mode, we just arrow over, and that's what I want for this first set of problems. And then I'll just go back to a blank screen. So here, oops, what did I say? I want degree mode. What did I put it in? Yes, I want degree mode. All right, so if I put in cosine of 25, just calculating really quick, it says 0.9063. And in the directions, make sure you're reading the directions to find out how they want you to express your answer. And in this case, it says round to 3 decimal places, or approximate to 3 decimal places. So 3 numbers after the decimal. All right, so the next few, you can go ahead and practice on your own. I'm not going to type those in, but just practice typing them in. If you're working with the reciprocal functions like cosecant, this would be the same as 1 over sine of 21 degrees. Okay. Cotangent would be 1 over tangent of 10 degrees. Okay. Then when we get to this one, sine squared of 40 plus cosine squared of 40, when you're putting that in your calculator, you have to put the angle measure in first, then you can square it, and it will square on the outside of the parentheses, but the calculator knows that it's supposed to be whatever this value is, sine of 40 squared. Then I'm going to add cosine of 40 and square that, and I get a 1. All right, so even though I can't get my exponent next to the cosine like it has in the problem, this means the same thing. Okay, and this is actually one of our identities. If you have an angle, any angle, if you have the sine of that squared and the cosine of that same angle squared, you're always going to get 1. This last one here, if I have sine of an angle and cosecant of the same angle, these are reciprocals of each other. So if I do sine of the angle and and 1 over sine of the angle, these are going to actually cancel out and we'll get 1. Okay, so if you're working with the reciprocal functions with cosecant, secant, and cotangent, you need to write them as 1 over the sine, cosine, or tangent, whichever one is indicated. So in this next column, we have angles that are measured in radians. And I know that because unlike the left column here, I don't see a degree sign. So now in my calculator mode, I have to change to radian mode. So I just arrow over it and hit enter, or go to Desmos and change it on Desmos. But I'm just going to put in sine of pi over 5. So just typing that in, sine, and then I'm going to get pi, and then divide it by 5 and close the parentheses. And again, I'm approximating, so I'm rounding to 3 decimal places. So this would be 0.588. Okay, same thing with cosine of 5. But when I get to secant and cosecant, remember these are reciprocal functions. So I'm doing 1 over cosine of that angle measure. Okay. Then we are looking at inverse trig functions. And an inverse trig function is basically, if we remember, the inverse means to undo a function. So in the case of trig, if I have inverse sine of an angle, and I know what the sine of the angle is, let's say it's 1/2. I want to know what angle has a sine of 1/2. Okay, so to solve this, to find the angle, theta, I do inverse sine of 1/2 on my calculator. And this one I'm going to do in degrees. So to do inverse sine on Desmos, there actually is a button for inverse sine. If you're using a graphing calculator, it will be the sine -1 that's above the sine. So it's the second function, inverse sine. And if I have 1/2 or 0.5, that's a 30-degree angle. And I could have found that on my unit circle if I look for the sine value, which is the y coordinate. So if I look at the y coordinates, I see sine of 1/2 is 30 degrees, or pi over 6. Okay. There's a couple different ways that we can write or indicate an inverse trig function. We can just say inverse sine or inverse tangent. We can use the exponent of -1, which indicates an inverse function. Just like in the past we did f -1 of x. That represented the inverse of that function. And another way that is described for an inverse sine is called an arc sine. If you ever hear that term, arc sine, that is the inverse of sine. And like I said before, the inverse function undoes the sine function. So if I do sine of an angle and then I do the inverse of that, I get back to the angle. It's kind of like saying I have x plus 4 and I'm going to do the inverse of that, is subtract 4, I get back to x. All right, so cosine of an angle, and then if I do the inverse of that value, I'm going to get back to the angle. Now, when we're working with cosine, and sine. And I'm going to go back to our sine of an angle is 1/2. So we said that that was pi over 6 or 30 degrees. But I can also find sine of an angle being 1/2 at 150 degrees. All right, so anytime I'm looking for a sine or a cosine value on the unit circle, there's always two angles that happens with. So on this one, sine of square root, the sine of a number is square root of 3 over 2. This angle also has that same sign. So when we're working with inverse functions, we're only working in part of the unit circle. So if we're looking for sine functions, we're looking for the angle that's in between negative pi over 2 and pi over 2. And on this unit circle, negative pi over 2 is down here. Okay, if I start at 0, here's negative pi over 2 to positive pi over 2. So if we're working with sine or tangent, we're looking for the angles in quadrants 1 or 4. All right, so let's make a note of that. So this is quadrant 1 or quadrant 4. Same thing over here for tangent, quadrant 1 and quadrant 4. But for cosine, we're going to work between 0 and pi, and that would be this upper part of the unit circle. Between 0 and pi, that's quadrants 1 and 2. So if we have an angle that is in a quadrant that is not part of our domain, we have to find a similar angle that's in part of our domain. And we'll do an example of that in a little bit. All right, so that's basically, we're going to use that as a reference when we get to the next page. But down here we have a triangle, and these pictures were left off of your notes, so you're going to have to draw this in. And it's asking us to find the angle. And in this angle, we know that this side is 3, this side is 5. I don't know what this side is, but I can calculate it, and technically that would be 4. But knowing that isn't really going to help us find the measure of that angle. So what I need to do is look for a trig function that involves the information that was given. So in this case, the side opposite of that angle was 3, and the side that is the hypotenuse is 5. So the trig function that involves opposite and hypotenuse is sine. So I want to find that angle that the inverse of sine is 3/5. All right, so to find this angle, I'm going to do the inverse sine of 3/5, and that's going to give me the angle measure. So on my calculator, I'm going to go back here. I'm still working in degrees, so I'm going to type in inverse sine, and then I have 3/5, and that will tell me that my angle is 36.87 degrees. So 36.87 degrees is the measure of my angle. All right, so here's another one. This time I know the side adjacent to my angle and the hypotenuse. So the trig function that involves the side adjacent and the hypotenuse is cosine. Okay, so the side adjacent is 5 and the hypotenuse is 13. So I'm going to do, whoops, not sine, cosine inverse of 5 over 13 and that's going to give me my angle. All right, so I can probably start this a little bit better, where cosine of this angle is 5/13. To find the angle, I'm going to do the inverse cosine of 5/13, and I do that on my calculator, and I'm going to have an angle measure of what is that number? 67.38. And I measured in degrees, so I have to put a degree sign there. All right, this triangle, I have the side adjacent to my angle and the opposite. That's the information I know, opposite and adjacent, and that would be tangent is opposite over adjacent. So this would be 4/3. To find the value of that angle, I'm going to do tangent inverse of 4 divided by 3 equals my angle. All right, so on my calculator, inverse tangent, 4 divided by 3, and my angle is 53.13 degrees. Okay, so in example 5, it's asking us to find the approximate value of the angle, and it doesn't tell us here how they want us to measure the angle. So because we're using our calculator here, we're going to measure this in degrees. And when it says approximate, that's basically when we're using our calculator. So if we're using our calculator, let's measure in degrees unless they tell us otherwise. So all I have to do is type in inverse sine, and I have 1/3, and that's a 19.47 degree angle. Okay. If I type in inverse sine of -1/4, I'm going to get negative 14.47 degrees. Now in example 6, this is where we're using our unit circle, and this is where our domain is going to kind of come into play here. So I just rewrote our domain here as a reminder. But if I'm looking for the inverse sine of 1, this means what angle has a sine of 1? All right, so on this, I can refer to my unit circle, and remember the sine is the y quadrant, and I have, or a y coordinate, and I have a sine of 1 at pi/2, and that's the only one. So the sine of pi/2 is going to be 1. So this is, my angle is pi/2. All right, so inverse sine of -1/2. Which value, which angle has a sine of -1/2? If I look at my unit circle, -1/2 is here, and it's also over here. So I actually have two angles that have a sine of -1/2. And this is where our domain comes in, because we're only looking for angles that are between -pi/2 and pi/2. Okay, looking in quadrant 1 and 4. So I'm not looking in quadrant 2 and 3, and I'm basically looking at this angle right here. But I'm going to name it as a negative angle. So if I start here and go backwards, remember this is 2 pi, or 12 pi over 6. And if I go backwards, this is negative pi over 6, which fits in our domain. Okay. In part C, we have inverse sine of pi over 8. Well, on this one, we can see that we have the inverse sine of a sine, and our answer is going to be pi over 8. The next one looks pretty similar. We have an inverse sine of 5 pi over 8, which technically this is not in my domain. Not in my domain. All right, so if I look at where 5 pi over 8 is, I don't necessarily have this on my unit circle, but 5 pi over 8 is going to be a little bit past 4 pi over 8, which is pi over 2. All right, so 5 pi over 8 is here, and if I were to draw this on a unit circle, so here's 5 pi over 8, and if I reflect it over the y-axis, this is actually going to be the angle that would have the same pi, because remember, or the same sign, because remember, there are two angles on the unit circle that have the same sign and the same cosine. So if this is 5 pi over 8 and I reflect it over the y-axis, which is 4 pi over 8, this angle right here is going to be 3 pi over 8. So 5 pi over 8, again, not in my domain. So if I put sine negative 1 of sine of 3 pi over 8, this now would be in our domain. And now the sine and the inverse sine will cancel each other out. And my answer now is in the domain for inverse sine. So this is 3 pi over 8. Okay. Part E, I'm looking for a cosine that has negative square root of 2 over 2. Now remember, cosine, inverse cosine, has a domain of 0 to pi. So I want negative square root of 2 over 2. Zoom back out here. So here's a cosine, the x-coordinate of square root of 2 over 2. So negative square root of 2 over 2 is going to be this angle right here, which is 3 pi over 4. So my angle that has, negative square root of 2 over 2 as a cosine is 3 pi over 4. Which angle has a cosine of 1? Okay, so cosine of 1, first coordinate, the x-coordinate is 1, and that would be a 0-degree angle. So this is 0. Then I have cosine inverse of cosine. So here we have the cosine and the inverse cancel out, but let's find out where pi over 12 is on my unit circle. So pi over 12 is half of pi over 6, so that would be right here. And we're looking in quadrants 1 and 4. So cosine and inverse and cosine, right here, are going to cancel each other out, and we just have pi over 12. The next one, inverse cosine of 2 pi over 3. negative 2 pi over 3. So if I go to negative 2 pi over 3, this would be 1 pi over 3. This is 2 pi over 3. But cosine is not, my inverse cosine, 5 pi over 3, is not in my domain. So let's think of our odd and even functions. Because cosine is even, this value right here, because it's even, is going to be the same as cosine of positive 2 pi over 3. All right, so this is the same reference angle. This has the same cosine value, but now it's in quadrant 1. Okay, and now if I take the inverse cosine, I can cancel these out, and I have 2 pi over 3 is my angle. Part I, I'm looking for a value of tangent being 1. So that means I have the same number for sine and cosine, and that happens at pi over 4. So if my tangent is 1, I have to have sine and cosine be the same, so the angle that happens at is pi over 4. And the last one, this is probably the hardest one. I want to know what angle has a tangent of negative square root of 3. All right, so tangent is negative in quadrant 4 and quadrant 2. All right, so tangent is negative in quadrants 2 and 4. And if I look at my domain here for inverse tangent, I can only look at quadrants 1 and 4. So I'm looking for an angle in quadrant 4 that has negative square root of 3 as a tangent. Now, negative square root of 3, if I'm looking at tangent being sine over cosine, and I want negative square root of 3 to be on top, I need a sine with negative square root of 3 in the numerator. So this would be, let's try this, negative square root of 3 over 2 divided by 1/2. So this is negative square root of 3 over 2 divided by 1/2. And this is going to cancel, just like multiplying by the reciprocal. So this gives me negative square root of 3. So what angle was that? Negative square root of 3 over 2 divided by 1/2 is 5 pi over 3. All right, so my angle is 5 pi over 3. But this is not in, this is not between negative pi over 2 and pi over 2. But if I take this same angle right here and I figure out how to get this back here, this is 1 pi over 3, 2 pi over 3. So 5 pi over 3 is the same thing as negative 2 pi over 3. And this is going to take a bit of practice. So that's what we're going to be doing a lot in our homework, is referring back to our unit circle to help us determine these angles used in the trig functions.